This video is looking at the presentation and display of data, which is important for psychologists because they want to be able to accurately communicate the findings of their research to other psychologists and to others interested who might be reading their articles. The different types of graphical displays that a psychologist might choose to use include graphs, tables, scattergrams, bar charts, and histograms, amongst others. And the type of graph that they choose to use is going to be dependent on the type of data that they're wanting to display. So we'll be having a look at the different types of data and the best ways to display those in this video. First of all, just some general rules for displaying any type of quantitative data, quantitative being data that is in a numerical form. They should really clearly show the findings in an easily readable format, which means that at first glance you should be able to have a look at a table or a scattergram or a bar chart, for example, and be able to get a gist of the findings of the research just at first glance. We need to make sure that any graphical display has a short but informative title, and the title is often forgotten by students, but it's absolutely crucial to include in any display of data. Our title usually includes the IV and the DV. We need to clearly label both of our axes. And we need to accurately plot our data, so it means interpreting the data from a table and accurately plotting that in a bar chart, for example, just making sure that all of those data points are correct and accurate. Now, I've got two top tips for you here that I don't want to put in writing, but I think they're really useful for you to know. In an exam, if you're asked to display any quantitative data, if you're asked to draw a graph, for example, there will be 4 marks allocated to that question. You'll get 1 mark for an accurate title that contains the IV and the DV. You'll get 1 mark for correctly labelling the x-axis, and you'll get another mark for correctly labelling the y-axis, which means that 3 out of 4 of your marks come from not plotting the data at all. If you think about how long it might take to actually plot a bar chart or a scattergram, for example, that could take you 5 minutes, and that's only going to be worth 1 mark. So, my advice to you would be, first of all, write the title. There, you've got your 1 mark. Then label your axes. There you've got an extra 2 marks. And already you've got 3 out of 4 marks without even having to draw a graph. So I would always do the title and the axes first, go on to answer any other questions in the paper, and then if and when you've got time later on, come back and accurately plot your data. The other tip concerns the title. Now, if you're asked to draw a graph, for instance, a bar chart, the data will first be displayed to you in the form of a table, and that table is always going to have its own title. So as we'll see later on, all I want you to do is pinch the title that you've already been given and write it in your graphical display. So we'll come to that in just a moment. So let's have a look at the different ways you might choose to display your data. The first and probably most common one is in the form of a table. Now, tables summarise the main findings of your research in the form of descriptive statistics. And as you know, descriptive statistics include the measures of dispersion, so our range and standard deviation, and also our measures of central tendency, our mean, our median, and our mode. So usually we don't display raw data in tables. Usually it's already been summarised and is already in a descriptive form. So for instance, here you can see the findings and a table from Godden and Badley's research into context-dependent forgetting. So here we can see a clear title, the mean number of words recalled in experiment 1 as a function of learning and recall. So here we've got our variables. We have down here the learning environments, and as we know, they learnt either on land or underwater. And then we've got our recall environment, we've got on land and underwater. And we can see, just by looking at this table, we can already get a feel for the results here. When we look at the congruent conditions, the learning on land and recalling on land, we can see a higher mean recall score. Likewise, for learning underwater and recalling underwater, we can see a higher mean recall score there in comparison to the incongruent conditions. So, without having to really delve into these findings too much, just by looking at this table, we get a sense that learning and recalling in congruent conditions is going to lead to superior recall than learning and recalling in incongruent conditions. So, this is a little bit more complicated than any tables you're going to be required to analyse. These are the ones that are most likely to come up in an A-level paper. So a little bit more simple. You'll see here that you've got a title, so percentage of friendly and aggressive social interactions in dreams reported by males and females. You can see here that we've got the friendly and aggressive content in the dreams, and we can see here that we've got the gender of our participants. We can see here we've also got our title. This one is data from a scattergram. that's displayed in table form. So this is a self-esteem score and negative self-esteem score for each patient. So we can see here that we've got 10 participants, n equals 10. And we can see that for each of these 10 participants, they've got a self-esteem score and a negative schema score. And we can use the information in this graph to then display this in a scattergram, and we can have a look then at the strength and direction of any correlation between self-esteem and negative schema. All right. Not only do you need to be able to draw a graph from a table, but it's really important that you're able to actually interpret the findings from a table. In any psychological report, we always have a table that's displaying the descriptive statistics, the mean and standard deviation, for example. And then following that, there's always a summary paragraph that is summarizing and interpreting what those findings mean. So in order to do this, you need to make sure that for every row and column, you mention the data that's in them, so that you're not forgetting any rows or columns. They're all mentioned in your summary paragraph. And summarize is the key word. Rather than simply repeat the data that is in the table, you need to actually digest it, and you need to make some sort of comment on what it means. So the cheat for doing this is making sure that you're using comparative terms. Like, if we just go back, so males reported more aggressive interactions in dreams than friendly interactions in dreams, for example. So that word more there is kind of key, because that's interpreting rather than simply just repeating the data. And then we need to provide an interpretation. So what does this mean then? What could you say about the differences between males and females in dream content? So if we just have a look at what that actually means in practice. Now, a question is likely to say, what do the means and standard deviations of the table suggest about the findings, or the psychologist's results? So here again, we can see we've got our title, which contains our variables. So a table showing the mean number of words spoken in 5 minutes and the standard deviation following consumption of Red Bull and water. So let's just take this mean row for the moment. So we can see that the mean number of words spoken 5 minutes after drinking Red Bull is 96, and that the mean number of words spoken after drinking water is 9.9. Already I can see that the number of mean words spoken in the Red Bull group is much, much higher than the number of words spoken in the water group. But how much? It's important that we make some sort of commentary on just how great that difference is. So below I've got a sample paragraph for you which summarizes the mean values in this table. So the mean values indicate that the number of words spoken following consumption of Red Bull, and here we've got a repetition of the data, was nearly 10 times greater. This greater is your key word. You must make that commentary than the words spoken following consumption of water. And there we've got the data for water as well. If you don't include the data for the Red Bull and the water groups, you're not actually going to lose any marks. What the examiner's looking for is this. They're looking for you to say that it was greater and by how much, roughly. Then you need to make some sort of interpretation of these results. Okay, so the number of mean words spoken after Red Bull was greater than the number of words spoken after water. So what? This suggests that drinking an energy drink makes people more talkative than drinking water. And that will be getting you 3 to 4 marks. Likewise, we can do the same for standard deviation. Remember, standard deviation is a measure of dispersion, which tells us how spread out the scores are from the mean. So we can see here that in the Red Bull group, we've got a larger dispersion than we do in the water group. So what does this mean? Let's have a look at our summary paragraph. The standard deviation is twice as high in the Red Bull condition, suggesting that there was a larger spread of scores in the water condition. Remember, we've got our comparative term there. This suggests that not all participants were equally affected by the energy drinks. In the water condition, scores were clustered around the mean to a greater degree. So you can see here that we're not just simply repeating the data, we're actually interpreting it. We're saying that there was a larger spread of scores because the standard deviation was twice as high in the Red Bull compared to the water conditions. And then we're providing a little bit of a commentary on what exactly that means in terms of the spread and dispersion of those scores. So for interpreting tables, it's really, really important that you're not just simply repeating the data in sentence form. You need to make some sort of interpretation and then commentary on what that means. All right, so a Apart from tables, bar charts are probably our next most common type of graphical display. And bar charts show nominal or categorical data. So some examples of categorical data are race, sex, age group, marital status, income bracket, education level. What we mean by this is basically that there are discrete groups. So you're either, in this case, drinking Red Bull or water. You're either earning over £50,000 a year or under £50,000 a year. So we're looking at categories of data where there are discrete options. So bar charts will always show nominal or categorical data. They can display percentages, they can display means, as we've got here, totals, so total number of words recalled, or ratios either. So the y-axis is a little bit more variable than the x-axis. And we can also display two or more values together. So if we've got more than one independent variable, for example, as we've got here, we can display all of that together. So here we've got a bar chart showing the percentage of adults aged over 18 years, with or without psychological distress, who are current smokers, and this is displayed by age group and level of distress. So we've got our title, which contains all of our variables. We've got our labelled axes here, so we can see along the x-axis we've got our age group, and we've got our levels of IV here as well. So we've got 18 to 44, 45 to 64, and greater than 65 plus years. And then over here on our y-axis, we've got the percentage who are currently smokers. The researchers here have also displayed this data in terms of another variable, and that is the level of psychological distress that people are showing. What you're going to notice here is that there are gaps between our bars, and that is absolutely crucial in any bar chart. Because we're dealing with discrete categorical data, our bars cannot be touching, and this includes a gap here between our first bar and our axis. You must always, with a bar chart, ensure that there are gaps between your bars. If we just go back for a moment, when we're displaying bar charts, usually our x-axis is our independent variable, and we've got our levels of the IV here. So in this case, our independent variable was the type of drink that our participants consumed, either Red Bull or water. And our y-axis is usually our dependent variable. In this case, what the researchers were measuring, which is the number of words spoken after in the 5 minutes following the drink. Alright, so that's for discrete, nominal or categorical data, but what happens if the data is ordinal or continuous? This is where a histogram is really handy. So when we're talking about continuous data, this is data that can take any value. So unlike categorical or nominal data, which can only take certain values, for instance, either Red Bull or water, continuous data consists of values like height, weight, length, temperature, etc. So it's where there is continuity between our data. So for instance, it could be test scores or percentage on a test, where you can score anywhere between 0 and 100. So if we have a look here, we've got our continuous scores are placed along the x-axis, and we've got frequency always displayed on the y-axis in a histogram. You'll notice here that the bars actually are touching, and that's because between 20 and 30, 30 and 40, it's all continuous. They are touching. Whereas before, in the discrete categories, Red Bull was separate to water, and so we needed a gap there between those bars to really clearly demonstrate that. What's missing from this histogram? A title. Alright, so here we've got another example. So here we've got a table, and what that would look like in a histogram. So if we have a look at our table, first of all, this is a frequency table showing a hypothetical distribution of scores on the Rosenberg self-esteem scale. So the number of participants who reported a self-esteem score of 24 is 3. The frequency of a score of 23 is 5. We can see here that the most frequently occurring score is a 22. So this is our mode. And we can see here the frequency of the rest of these scores as well. So what happens when we plot these? We can see that a score of 15 at the bottom here, this is our lowest score, there is a frequency of 1, 16, 2, and so on and so forth. Now this is really handy because this allows us to see the distribution of scores. So when we look at the normal distribution and we look at skewed distributions, we're going to be coming back to these histograms. But basically it tells us this. So just to sum up, the difference between a bar chart and a histogram. Bar charts have gaps between the bars because they're displaying discrete categorical data. So data that can only take certain values. In this case, you can be speaking Spanish or Chinese or Hindi or French or English. In a histogram, the lines are touching. And this is because the data is continuous. So something like age, height, year, for example, is all continuous data that is best presented on a histogram. All right. Now, although not listed in the spec, it's useful to know as well that line graphs are often used by psychologists or sometimes referred to as frequency polygons. They're really no different from a histogram. This is also showing continuous data, but in this case, we just draw a line from where those points would be on a histogram. So I'm just drawing in those bars here, although those bars should be touching. And we just draw a dot on the top of those bars and then we join them together. Now this is really useful and is often used over a histogram because it allows us to plot various different variables. So if we've got a changing variable over time and we've got multiple independent variables, then a line graph is often more appropriate than a histogram. So for example, if we wanted to look at the scores of teachers teaching psychology, the results of their A-level students between 2000 and 2020, we'll display that on a line graph because we've got more than one teacher. And so we want to look at how the scores for each teacher change over time. So we'll be plotting both their scores as a line graph with year as our continuous data on the x-axis, and then the scores or the UCAS points, for example, on the y-axis. Another way to display graphical data is a scattergram. Now, I'm not going to go into this too much because I know that you've covered this elsewhere, but just to summarize, a scattergram is for correlational data. So it's data where we're looking for a relationship rather than a difference. So we're looking for the relationship here between covariables. So if we have a look at our example, this is a scattergram showing the relationship between the number of hours spent revising and exam score. So it doesn't matter which one you put on which axis because they're both covariables. But we can see here we've got exam score percentage down there on the x-axis and the number of hours spent revising there on the y-axis. So one is plotted on the x and one is plotted on the y. If we have a look here, each of these crosses signifies one student. So we can see that this student here, their exam score, not so great. So they're looking at perhaps 1 or 2% here. The number of total hours they spent revising was 26. So each of these is the intersection of those 2 points. Now a scattergram gives us an indication of both the direction, so either positive or negative, and also the strength of a correlation. It doesn't tell us whether it's significant. For that we need inferential statistics. But it does tell us the direction and the strength of a correlation. So this one here, I want you just having a look at these examples and thinking to yourself whether this is positive or negative, and then having a look at the strengths of each of these correlations and just see if you can do that for a moment. Of course, with this first one here, we're looking at a positive correlation. So as one variable increases, so too does the other one. For our next one underneath that, we're looking at a negative correlation. So as one variable increases, this one decreases. And if we have a look at the strengths of our correlations, here we're really looking at the amount of scatter there is. So we can see here that most of these scores are clustering around the mean. And so this is a strong correlation. We've got less scatter, meaning a stronger correlation. Here we've got a little bit more scatter. So this is looking at a moderate correlation. And here we've got a lot of scatter. So that's a weak correlation there. Remember, correlational data is really useful because it provides us with a correlation coefficient, which tells us, again, in a numerical form rather than a graphical form, the strength and direction of a correlation. So just to remind you, the stronger the correlation, the nearer it is to either -1 for a perfect negative correlation, or +1 for a perfect positive correlation. 0 would indicate no correlation at all. So if we see a negative, we know there's a negative correlation, positive, positive correlation. All right, and although rare, you may be asked to evaluate or provide a justification for using, for example, a histogram over a bar chart. So the strengths and the weaknesses of each type of graphical display really just depends on what type of data it is or is not able to display. So for instance, is it displaying discrete data or continuous data? Can it display multiple IVs like we see in a line graph? Does it show changes over time like we see in a line graph, etc.? So long as you know when it is appropriate to use each type of graphical display, you'll be able to evaluate them just simply by saying a strength of bar charts is that they're able to display categorical data, whereas a histogram can only display continuous data.